Welcome to Naradar Academy. In this video, we are going to discuss about limiting points of a sequence, which is otherwise called cluster point. And also we are going to discuss what is meant by limit superior and limit inferior, and what is the relation between limit superior, limit inferior with limit of the sequence. Okay, let's start with the definition of limiting point or a cluster point. See, a real number p is said to be a cluster point or a limiting point of a sequence if for each epsilon greater than 0 and for each positive integer m, there exists a positive integer m naught which is greater than m such that p minus epsilon to p plus epsilon contains this a m naught. That means, see, I have a sequence an. Okay, this is a sequence and I have a point p, real number p. This will be called as a limiting point or a cluster point for this sequence if every neighborhood for this real number, okay, neighborhood means what? The open interval p minus epsilon to p plus epsilon is a neighborhood. Okay, by varying epsilon we will get different neighborhoods for the given point. Okay, so for this sequence, this point is a limiting point if for every epsilon greater than 0, this open interval p minus epsilon to p plus epsilon contains a point a m naught where this m naught is greater than m. What is this m? M is a positive integer. Okay, so for this is a pair, that is epsilon and m is a pair. For given epsilon and given m, we can find some a m naught which lies between p minus epsilon to p plus epsilon. This is the definition for limiting point or cluster point for a sequence. See, already we have seen what is meant by a limit point for a given set of real numbers. Okay, and also for sequence we have studied what is meant by limit of the sequence. Okay, so all these things we have studied. So this limiting point will contain properties of all these things together. Okay, right. Now we know the limit of a sequence, if it exists, is a unique number, but this limiting point is not unique. Okay, a sequence may have one or more limiting points. Okay, right. Let's see some example. Consider the sequence minus 1 power n. So what are the terms of this sequence? Only minus 1 plus 1 minus 1 plus 1 minus 1 plus 1. So both the points minus 1 and plus 1 are cluster points for this sequence. And then what is this sequence? an equal to 1 by n. This is a very well known sequence that it has only what? One cluster point 0. Okay, right? This sequence is a convergent sequence, and what is the limit of this sequence? 0, isn't it? And that 0 is the cluster point. So from this what can you see is, see, if a sequence is a convergent sequence and if it has a limit, then it will have only one cluster point or only one limiting point, that is its limit of the sequence. If the sequence is not convergent, it may have two or more limiting points or two or more cluster points. For example, this is an oscillating sequence. No, this is an oscillating sequence which oscillates between minus 1 and plus 1. So these 2 points are called what? Limiting points or cluster points for the sequence. Okay, next one is this sequence an equal to n, that is 1, 2, 3, 4, 5, etc. Actually we know that this is a divergent sequence and it does not have any limits, and the same way it does not have any cluster points also, because whatever real number you take, okay, this is nothing but natural numbers. No, 1, 2, 3, 4, 5, whatever real number you take in the neighborhood, you cannot find any point of this sequence. So this sequence has no cluster points. Okay, so this is the property I have explained here. So if we have a sequence which is converging to L, then L is the only cluster point. Okay, so convergent sequence has only one cluster point, that is its limit. Next one, Bolzano-Weierstrass theorem for sequence. Every bounded sequence has a cluster point. Okay, the converse need not be true. Okay, right. So what we have here, every bounded sequence. So if you are given with a bounded sequence, then you can surely say that it has a cluster point. See, this is a bounded sequence, no, because lower limit is minus 1 and upper limit is plus 1. So definitely it will have a cluster point. and this is also a bounded sequence. Upper bound is 1 and lower bound is 0. So this is also having cluster points, and this is not a bounded sequence. Okay, right. Next one, let F be a closed and bounded set in R, then every sequence in F has a cluster point in F. So the closed and bounded set in R definitely has every sequence in it has a cluster point. Okay, next one. Limit superior and limit inferior of a sequence. See, let an be a bounded sequence. Okay, then it will have cluster points. No, you collect all the cluster points for this sequence. Okay, the set of all cluster points will have a greatest member. No, that is called the limit superior, and the least member of the set of all cluster points is called the limit inferior. Okay, so what do you mean by limit superior and limit inferior? For the given sequence, you collect the collection of all cluster points. In the collection of all cluster points, the greatest member is called limit superior and the least member is called what? Limit inferior. Okay, right. And the notation is for limit superior, we write LIM. LIM means what? Limit superior, SUP we write. Otherwise, we can write limit one bar in the above the limit. If you put one dash, no, that will denote limit superior. For limit inferior, either we can write it like this or we can put a bar under the limit sign. Okay, so these are the definitions for limit superior and limit inferior. As I already told you, if your sequence is a convergent sequence, then it will have only the limit as its cluster point. So that will be its limit superior and limit inferior. Both will be equal when the sequence is a convergent sequence. Okay. Now let's see some examples. See, look at this sequence. This is what we have already seen. This sequence has two cluster points. One is -1 and another one is +1. So the least member is what? -1, and it is the inferior, limit inferior, and the greatest member is +1 and it is the limit superior. Okay, next, this is another sequence. See, this sequence is defined in three different ways. For n taking the values 1, 4, 7, it is 1 plus 1 by n. For n equal to 258, it is 2 plus 1 by n. For n equal to 369, it is 3 plus 1 by n. So what are the limit superior? Definitely the sequence is bounded, isn't it? Okay, so all the values will be greater than 1 only and all the values will be less than 4, isn't it? So from the definition itself we can find out this is a bounded sequence. By Bolzano-Weierstrass theorem, every bounded sequence has a cluster point. So this will definitely have cluster points. So what are the cluster points? See, 1/3 of the points are one third of the points are clustered around 1, and another 1/3 of the points are clustered around 2, and another 1/3 is clustered around 3. So these 3 points are the cluster points, that is 1, 2, 3. From the definition itself you see, by putting n equal to 1, 4, 7, all these points will be lying near 1. All these points by putting 2, 5, 8 will be lying near 2. All the points obtained here by putting n equal to 3, 6, 9 will be lying near 3. So these 3 points 1, 2, 3 are the cluster points. So among which the greatest member 3 is the limit superior and the least member 1 is the limit inferior. Okay, and again the same sequence an equal to 1 by n. So this sequence we know this is a convergent sequence and it converges to 0. So both limit superior and limit inferior are equal to limit of the sequence. Okay, that's all. Thank you.